example page 27. We have a pipe arrangement and different cross sections. We start with the cross section 1, A1, there we have a cross section A2, there the cross section A3 and A4 and A5, and then we have the velocities U1, U2, U3, U4 and U4. So given are these parameters, U1 is 1 meter per second and the diameter is 10 millimeters, U2 is 4 meters per second and the diameter in the position 2 is 5 millimeters, U3 is 100 meter per second and the diameter is 1 millimeter, and U4 is 4 meter per second and the diameter D4 again 5 millimeters, like in this cross section A2. So we need the kinematic viscosity 30 square millimeters per second, and the question is the flow laminar or turbulent in the several cross sections. And here we write down the definition of the Reynolds number. Reynolds number in the position x is the velocity in the position x multiplied with the diameter in the position x divided by the kinematic viscosity. And in the on the next page we will calculate the Reynolds numbers in the different cross sections. So we bring together the diameter, the velocity and the kinematic viscosity. So in this position we have 500. Here in this position we have 250, where some Reynolds number. In this position we have 500. Here we have this 100 meters per second, means 100,000 millimeters per second, times diameter 1 millimeter divided by kinematic viscosity 40 square millimeters per second. Then we get 2500 in this position as a Reynolds number. The Reynolds number in position 4 is the same Reynolds number as in position 2, because we have to say it's the same parameters there, 500. And now we can judge this flow here. We can say the flow will be turbulent at the cross section A3 because the Reynolds number 2500 is larger than the critical Reynolds number 2300. The result is turbulent. Then in the following section, which is A4, then we will have downstream this throttle here. Then we will again have Reynolds number 500, because 500 is the magnitude under 2300 divided by 2. Yes. Then we can say here we have laminar flow again. And here I sketch the result, which means here we have laminar flow because the Reynolds number is lower than 500. Here we have turbulent flow because the Reynolds number is larger than 2300, and here we have laminar flow again because the Reynolds number is reduced to a magnitude which is lower than the half part of the critical Reynolds number, and the result is that we get here again laminar flow.